Imagine a building the size of a city block, weighing 23,000 tons, hanging in midair over the open ocean. That entire structure, the helidecks, the flare booms, the accommodation blocks, is being lifted off its foundations in a single, uninterrupted move. That 23,000-ton deck sits on a steel jacket weighing another 12,000 tons beneath the waterline. If you stacked this assembly against a modern cruise ship, the platform would outweigh it. Moving 35,000 tons of steel in one go is a massive feat of heavy engineering. Yet in terms of time and complexity, the lift is the shortest, easiest part of the entire operation. The North Sea is crowded with aging infrastructure. Hundreds of these platforms have pumped their reservoirs dry and ceased production. Under international maritime law, operators cannot simply walk away. They are legally obligated to remove every trace of the steel they put there. Leaving a rusting, decaying maze of pipes and live electrical systems unattended in the middle of one of the busiest shipping lanes on Earth is an environmental disaster waiting to happen. This chart illustrates the timeline for a recently awarded removal contract. On the far right, you see the heavy lift itself. It takes a few hours, but this massive block on the left shows the required preparatory work. That takes 8 full years. You cannot just hook up a crane and rip a hydrocarbon facility out of the water. To remove it, you first have to safely dismantle what is essentially a highly pressurized bomb. Building a platform requires a strict commissioning sequence. Tearing one down is that exact discipline executed backward. First, the purge. Every vessel and pipeline is flushed with nitrogen so no explosive gas remains. Then, the darkening. Engineers isolate high-voltage switchboards and route temporary power. The margins for error here are zero. If a single pocket of pressurized gas or one live high-voltage cable is missed during isolation, a single spark during the steel cutting process will instantly destroy the entire rig and the massive heavy lift vessel parked directly beside it. A platform is incredibly dangerous when it is pumping oil, but it is at its absolute most volatile right now, when its systems are half alive and being systematically blinded. Because of that volatility, you cannot just pull the main breaker and shut the facility down all at once. The platform's emergency shutdown logic and its fire and gas detection loops have to remain fully armed and monitoring the deck the entire time the crew is working. This creates an engineering nightmare. You have to keep highly sensitive safety computers perfectly powered and functional, even as you dismantle the permanent power grid they were originally designed to run on. The facility only truly dies when that final safety matrix is formally powered down and retired, usually mere minutes before the last remaining worker steps off the cold deck and onto a waiting helicopter. There is no heavy machinery that can do this isolation work. Every purged pipe and killed circuit requires a human being to physically verify it. The real critical path taking up those 8 years is the paperwork. Thousands of physical signatures on isolation and gas-free certificates must be completed before a crane ship is legally allowed to approach. Once the signatures are in, the massive crane lifts the deck in a matter of hours, and the vessel begins the slow transit back to a Norwegian yard where the steel will be cut down and recycled. Clearing 35,000 tons of steel leaves a clean horizon, but the 8-year gap between production and removal is filled by those thousands of verified signatures. Removing the facility safely depends entirely on that unbroken chain of human accountability. Over the next 2 decades, hundreds of offshore platforms are scheduled to go through this exact same teardown sequence. But the industry is facing a severe talent bottleneck. Almost no engineering university or graduate scheme teaches students how to safely unbuild a live, pressurized hydrocarbon plant. That makes end-of-life electrical, instrumentation, and commissioning competence one of the rarest and most valuable skill sets in the modern energy sector. As this basin transitions from producing oil to managing scrap, the biggest winners will not be the companies that own the massive crane ships. The winners will be the companies that employ the few people who actually know how to safely turn the ocean off.